Fatul Izzah binti Saib Anwar, and my metric number is 305653, and I am from the group 10. So for the introduction, this set of questions focus on using mathematics to solve problems related to functions, costs, profits, and demands in business. So for the first question is finding the increasing and decreasing in the intervals. Next, find the profits in a monopoly. Then, minimizing a production cost, and lastly, the elasticity of demands. Each of the question use mathematical tools such as derivatives and formulas. For the question 1a is to find the intervals where the function fx equal to 2x cubed plus 3x squared minus 36x plus 4 is increasing, and the interval where it is decreasing. So for the first step is to find the first derivative from the function fx equal to 2x cubed plus 3x squared minus 36x plus 4. Then we get f prime x equal to 6x squared plus 6x minus 36. So for the next step is to find the points from the function f prime x, where 6x squared plus 6x minus 36 must be equal to 0. Then we can divide it by 6 and we can factor it. Then we get the answer where x equal to -3 and x equal to 2. Next step is to test intervals around points. So for the first intervals where -infinity with -3. So let's say that x equal to -4. So f prime times -4 equals to 6 times -4 square plus 6 times -4 minus 36. So we get positive 36. So f is increasing. Next, the intervals where -3 with 2. So let's say that x equal to 0. So f prime x times 0 equal to 6 times 0 square plus 6 times 0 minus 36. So we get -36. And of course, f is decreasing. And lastly, the intervals where 2 with infinity. So let's say that x equal to 3. F prime times 3 equals to 6 times 3 square plus 6 times 3 minus 36. So we get positive 36. So f is increasing. Okay, so f is increasing on the intervals -infinity with -3 and 2 with infinity, and it's decreasing on the interval -3 with 2.
Question B. First, find the marginal profit MP function. First of all, given demand equation is P equals 200 minus 0.98Q and total cost function is 0.02Q square plus 2Q plus 8,000. To find the marginal profit function, first of all, find the total revenue. Equation for total revenue is RQ equals P times Q. So given P is 200 minus 0.98Q times with Q and get 200Q minus 0.98Q square. After getting the total revenue, use it to find the profit function, which is PQ. So to find the profit function, total revenue needs to be subtract from total cost. So we need to solve it. 200Q minus 0.98Q square minus in bracket 0.02Q square plus 2Q plus 8,000. Develop the equation in bracket, right back, and we will get 200Q minus 0.98Q minus 0.02Q square minus 2Q minus 8,000. Solve it and rearrange the equation. After doing the calculation, I get the profit function is negative Q square plus 198Q minus 8,000. The last step to find the marginal profit is to find by using differentiating PQ. By using the formula MPQ equals to DPQ divided by DQ. Then the difference is the profit function, which is negative Q square plus 198Q plus minus 8,000. So, by using the basic rules of differentiation, the derivative of negative Q square is negative 2Q. The derivative of 198Q is 198, and the derivative of negative 8,000 is 0. And get the result after rearrangement is negative 2Q plus 198 plus 0. In conclusion, the marginal profit function is negative 2Q plus 198. Question number 2 of B is find the interval where the marginal profit is falling and rising. By using the answer from B, first, the marginal profit is negative 2Q plus 198. I provide 3 steps to answer this question. The first step is to set MPQ to 0 to solve Q. That is, MPQ will equals to 0. So by using the equation above, MPQ equals 2Q plus 198 equals to 0. Q after the calculation, Q is equal to 99. The second step is to analyze the behavior of MPQ. Given two situations, the first is when Q is less than 99. For example, Q equals to 98. Enter Q in the function MPQ. The negative 2 in bracket 98 plus 198 equals to 0. Solve it and we will get 2 equals to 0. This shows the MPQ, which is 2, is greater than 0, while the second situation is when Q is greater than 99. For example, Q equals to 100. Enter Q in the function MPQ, solve it and get negative 2 equals to 0. This shows the MPQ, which is negative 2, is less than 0. The third step is the conclusion. By looking at the second step, I can conclude that marginal profit MPQ is rising when Q is smaller than 99 because MPQ is greater than 0, while marginal profit is falling when Q is larger than 99 because MPQ is less than 0.
Question B number 3. Determine the average profit or AP function. To determine the AP, we need to calculate the total profit or TP first. We will use the total profit formula, which is total revenue minus total cost. They already give the total cost in the question. What we need now, just total revenue. So, price or P times Q or quantity. We take the P equal to 200 minus 0.98 from the information given in the question and times it with the Q. We will get TR equal to 200Q minus 0.98Q square. Now we can find the total profit. 200Q minus 0.98Q square minus with 0.02Q square plus 2Q plus 8,000. Open the bracket. We get 200Q minus 0.98Q square minus 0.02Q square minus 2Q minus 8,000. Simplify it. 200Q minus 2Q minus 0.98Q square minus 0.02Q square minus 8,000. So our TP is 198Q minus Q square minus 8,000. Now we can finally find our average profit function. 198Q minus Q square minus 8,000 divided by Q. Simplify the equation and our final answer is AP equal to 198 minus Q minus 8,000 divided by Q. To determine the level of production at which the average cost SC is minimized, first find the SC using total cost or TC divided by the quantity or X formula. So we use the total cost given, which is 0.02 X squared plus 2X plus 8,000 and divide it with the X. And we will get 0.02X plus 2 plus 8,000 divided with X. Next, we differentiate the equation we just get. So derivative of 0.02X respect to X is 0.02. Because X is equal to the power of 1, if we want to differentiate it, we need to minus the power of 1 with 1. And derivative of 8,000 divided by X is negative 8,000 divided by X squared. Get this by times the negative 1 with 8,000. We get negative 8,000 and time with the X to the power of negative 1 minus negative 1. After that, set the derivative equal to 0 to find the minimum points. So, 0.02 minus 8,000 divided by X squared equal to 0. Then we rearrange the equation. So, negative 8,000 divided by X squared equal to 0.02. And then bring the X squared to the right side. So, 0.02 times with X squared. Next, we settle the equation by find the X. We divide both sides with 0.02 and we will get X squared equal to 400,000. To get the X, we need to take the square root of both sides. And our final answer is 632.46.
The demand function is given as Q equals 16 minus 2P to the power of 0.5. We need to find the price of elasticity of demand when Q equals 10. Substitute Q equals 10 into the demand function. 10 equals 16 minus 2P to the power of 0.5. Rearrange 2 isolate 2P to the power of 0.5. 2P to the power of 0.5 equals 16 minus 10 equals 15. Divide through by 2. P to the power of 0.5 equals 25. Square both sides to solve for P. P equal to the power of 0.5 square root 25 and we will get P equal 625. The demand function is Q equals 16 minus 2P to the power of 0.5. To calculate elasticity, we need dQ divided dP. dQ divided dP equal negative P negative to the power of 0.5. dQ divided dP equal negative 1 divided P to the power of 0.5. The formula for price elasticity of demand is ED equal dQ divided dP times P divided Q. So, negative 1 divided 625 times 625 divided 10 and we will get the answer is negative 2.5. The price of elasticity of demand when Q equals 10 is negative 2.5.